Okay, I wanted to show a sample on how to do some of the problems in 448 for the homework. On number 77 specifically, it says use trig substitution to write the algebraic expression as a trig function of theta, where theta is between 0 and pi over 2. That's the big clue, because that puts us in one of the quadrants. Do you know what quadrant? I hope you do, right? Between 0 and pi over 2, that's the first quadrant. So we're dealing with trig functions of right triangles here, so we draw a right triangle. And based on the clue we are given in number 77, and the problem in 77 says this, the square root of 9 minus x squared, and then they want us to use x equals 3 cosine theta. Well, if you look at this example here and try and think of what sides that could be on this right triangle, this is usually the x side, this is usually the y, right? And if I'm thinking 9 here, what do you think this side is before I squared it? Because all of these basically use the Pythagorean theorem, x squared plus y squared equals z squared, or whatever you want to call that other side. So if I'm doing 9 minus x squared equals to that side, right? This side here, it's not a 9, what is it? I hope you thought about it as a 3. So there's the right triangle that represents this problem. And this squared, so really I would have 9 squared equals x squared plus y squared. But here they change it around a little. 9 minus x squared equals y squared. And that's what we're dealing with, 9 minus x squared. All right, to solve this problem with x equal to 3 cosine theta, it's just a matter of substitution. So watch what happens here. 9 minus 3 cosine theta squared. Next step. 9 minus 9 cosine squared theta. You can do that, right? Now, how do you take the square root of this? The problem is, when I take the square root of something, if there's an algebraic expression inside, it needs to be a multiplication if I want to take the square root of each part. I can't do a 3 here and say 3 cosine theta because of that minus sign. So I need to get it as a multiplication. So first step might be to factor out a 9. And then I have 1 minus cosine squared theta. Still under the square root symbol, right? Now, I can do the square root of 9. I know that part's 3, but what do I do with this? I can't take the square root of that the way that it is. So then what you do is you look at your trusty trig identities that I gave you a handout about the trig identities. And it's one of the fundamental identities. Basically, it's one of the Pythagorean identities. You know the rule? Sine squared theta plus cosine squared theta equals 1. Well, if I solve that, 1 minus cosine squared, I can replace it with sine squared. So now I can write this as 9 sine squared theta. Now the whole thing's a multiplication. I can do the square root of it. Let me write it up here one more time. So square root of 9 sine squared theta is really the square root of 9 times the square root of sine squared theta. What's the square root of 9? Hope you said 3. What's the square root of sine squared? Sine. So 3 times sine theta. 3 sine theta. And there's your answer. These aren't so bad. You can do them. Make sure you have your identity page next to you so that you can figure out what identity to use. They're not always in terms of sine and cosine. Sometimes you're going to be tangent, cosecant, and the rest of them. Good luck.